Let's go ahead and leave the molar universe for just a moment. Nobody wants to get sucked in to a molar vortex, right? Bueller, probably don't know that reference, but I don't know, it's debatable. I think you should know that one. We're going to turn our attention now to making percent solutions. And you can think about these as the weight of the compound over the volume of the solvent you're going to use to bring it up to the desired volume. So weight by volume, percent solutions, and we come into the lab and we greet our colleagues and we've had our coffee and our hands aren't too shaky, and we are asked to prepare a 100% solution of none other than sodium chloride again. Wow, labs really like the sodium chloride. Can't beat good old-fashioned table salt, although in this case it's lab grade, but that's a different story. And we're going to go ahead and scale from 100%. So, hey, look at that. It's the same bottle. It's the same sodium chloride bottle that was on the shelf before, and you see the same information. It's still from the fantastic state of Iowa. Go Hawkeyes. But we are not interested anymore in knowing the molecular weight. In fact, when you're making a percent solution of anything, sodium chloride, sodium hydroxide, potassium chloride, the formula weight doesn't matter when you're making percent solutions. You just need to know what the percent you are making is and follow the following rules. And when I was actually in my first job, in that first lab, and I was asked to make a percent solution of sodium chloride, this great big, tall, lanky Italian postdoc in the lab named Massimo Moreghi. Massimo, I mean, come on, you can't get more Italian than that. Massimo Moreghi. I'm not making this up. That was his name. And he came over to me and said, "Crawford, you need to remember this, and remember this for all times." And he scared me so bad, I dropped my lab notebook right on the floor, but it worked because I never forgot what he had said. And that was to make a 100% solution of anything, 100 grams in 100 mils is 100%. And boy, that stuck with me. And again, 100 grams of what you're measuring out up to volume to a total of 100 mils. I don't care what it is, that delicious sodium chloride right there, don't eat it. Or any other lab compound. 100 grams up to 100 mils, that's 100%. And you can see that the formula weight does not even come into the picture. So that's for 100% solutions. And sometimes you will make a 100% solution. But that's not always the case. There's a lot of other percents between 0 and 100 to make and to think about. And we make them all in the lab. And so let's scale from there, right? Let's not get old math involved here. Let's scale instead. What if we wanted to make a 10% solution? Okay, a 10% solution. If I scaled from 100, well, that's a tenth of 100. 100 divided by 10 is 10, a 10% solution. A tenth of 100. Well, you know what? If you keep the volume the same, up to 100 mils, then you need a tenth as much of whatever you're weighing out, in this case, sodium chloride. So we're going to make that 10 grams. Do you see how 100 divided by 10 is 10? And so 100% goes to 10%, and 100 grams goes to 10 grams. The volume remains the same. We're just having less of the compound, and therefore less percent solution. Fantastic. Go ahead and pause that and think about it if you really need to right here. This is an important concept. I hope you paused it, and I hope you're back, and I hope you understand. We can keep scaling from there. By powers of 10, we're talking about moving decimal places. And because we're going from a bigger percent to a smaller one, we're moving that decimal place by a power of 10, 1 to the left. Let's do it again. Beyonce said something about to the left, something about everybody is to the left. I don't know. You might know that one better than I do. That's fine. So if we're going to go from 100% to 10% to 1%, waha, you are correct, my friends. Very good job. That's another division of 10. That's another move that decimal place 1 to the left, keep the total volume the same. We now have a 1% solution of 1 gram and up to volume to 100 mils. That's 1%. Okay? That's a tenth away from 10%. And that's 100th away from 100%. 1 over 100 times 100 is 1. You can keep going to your heart's content. What if we wanted 0.1 away from 1%? That's another tenth away. That's another movement of the decimal place 1 to the left, a power of 10 less. In what we're measuring out, we're going to keep that volume the same, and you guessed it, we've got 0.1 grams over 100 mils. And that's a thousandth, 1 over 1,000 times less than 100%. And 1 over 1,000 times less, you guessed it, is 1 times 10 to the negative 3 less than 100 in this case. 3 decimal places to the left we go. And so those powers of 10, all the way back to that first slide of metric conversions on the simplified scale, really pays off yet again. And I hope you can see that. We'll do some more exercises online here and in class to power home. Let's do an example. I think that's always important. You're going to have examples to do on your own, but we'll do one together here. Let's do 2 changes, okay, from our rule of 100%. We're going to make it a 0.1% solution, and we're also going to make it 500 mils. Okay, so 2 things change, the percent and the volume. So let's go ahead and go up to our little handy dandy chart, and let's pull down from the top our rule for 0.1%. 0.1 grams up to 100 mils is 0.1%. That sounds good, except we need a different volume. We need 500 mils. So what we want to do is scale accordingly from here. If 0.1 grams up to 100 mils here is 0.1%, we're multiplying 100 by 5 in this case to get 500 mils. And so accordingly, let's multiply our 0.1 grams by 5. And when we do that, we get 0.5 grams in 500 mils. So a 0.1% solution of sodium chloride in 500 mils is 0.5 grams and up to volume in 500 mils. So let's go ahead and wipe the board. Magic. The math is gone. And let's say that fantastic Italian postdoc who wears a suit and tie every time he goes to see the doctor, true story. Today in the lab, he wants you to make that same 0.1% sodium chloride solution. He wants the total volume to still be 500 mils. And he says, there's another way to get to that same result. And you freak out, but he wants you to take comfort in that. And the lesson here is that there are more than one way to get to the same answer. And so whichever logically makes sense to you is the way to go. Some people may like how I did it on the previous slide. Some people might like this one better. And some people might find a third way to do it. And you're all right as long as we get to the same answer. We all have fancy calculators. We can pull them out of our pocket, open up the phone app, and punch into the calculator and get the same answer. But if you don't know what to put into that calculator, that's the issue. And so let's make this less about math and more about logic, and let's all get to this in the way that makes the most sense to us. So on the previous slide, I thought to myself, okay, if I've got my rules of thumb up there at the top from 100% to 0.1%, and the game is changed where I have to consider a 0.1% solution and a different volume, I could change one or the other first. And as you see, we went for the 0.1% We considered that as the situation first and consider the volume later. On this example, we're going to take the same solution and consider the volume first and go for the percent later. So let's see how that works. Here, we're going to copy paste below our rule for 100%. We're going to think to ourselves, we remember very strongly that 100 grams and up to 100 mils is 100%, and we can't forget that. So we're going to just copy paste that down. But we're going to know that our volume changed by a factor of 5 times our rule. You can see there, we went from 100 mils to 500 mils in the denominator, and therefore we go from 100 grams to 500 grams. We're going to scale accordingly. Multiply the bottom by 5, multiply the top by 5. That is a 100% solution in 500 mils. But we're not interested in a 100% solution in 500 mils. We're interested in a 0.1% solution. And so what we have to do is now treat the problem of our percentage. So how do we do that? Well, let's carry over that 500 grams. We're only interested in how much of that sodium chloride in that bottle over there do I need to weigh out. So we'll carry that over, and we're going to multiply it by a factor that changes our 100% into a fraction for 0.1%. So that's why you see 0.1 over 100. Those percent signs are going to cancel out, leaving you with grams, and that'll tell you how much to weigh on your scale. Back to the powers of 10 we go. 0.1 over 100. You can reach for your calculator, and that's cool. And it's going to give you the same answer as what I'm going to tell you right here. If you're going to go 0.1 over 100, you're dividing by a bigger number. Your decimal point is going to move to the right or to the left. If you said left, you're correct. We're making a smaller number. 0.1 is going to become an even smaller number. How many decimal places do we have to move it? How many zeros are down there? 2 powers of 10. 2 zeros, 100. So let's move it 2 places to the left. If you divided 0.1 by 100, you're going to get 0.001. And so essentially this is 0.001 times 500, which turns out to be 0.5 grams. That's 0.5 grams. We're going to carry over our 500 mils from beginning because that's going to be the total volume. As you see here, 0.5 grams in 500 mils, just like on the last slide, is going to give us a 0.1% solution. A third way to have thought about this is going from the 500 grams and dealing with the percent as moving the decimal point right away. You could have thought to yourself, 0.1% converted as a fraction of 100% is 0.001, like we said. That would be like taking 1 and moving the decimal place 3 to the left. We just divided by 100 and moved it 2 from 0.1, but if we started from 1, that would be 3 to the left. Similarly, you could take your 500 grams and move the decimal place 3 to the left, and you're going to get 0.5 grams. So no matter how you slice it, you're going to end up in that right spot. So there's 3 ways to think about it, and whichever makes the most sense is the way you should go for it. So, in summary, so far, we've made 1 molar solution, and we've made a 100% solution of sodium chloride. Bravo! That's going to keep your boss and your coworkers happy for a little bit. When we move forward, you're going to put these to work. So bravo, take a break for a moment, pat yourself on the back. This is a win. You have to celebrate those wins, and we'll keep moving forward here in just a moment.